Get Certified Together program is created by Technocofe, your free online knowledge sharing website, based out in London.
In any system, we have this service account concept as well, where we create service account for the systems to talk within each other, and those service accounts will have their own identity. Now that identity doesn't mean that you are authorized to do something as well. So next concept comes is access management, which actually cover two things: authentication and authorization. Now authentication is something which on top of your identity help you
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.
Hello all, welcome to another episode of Get Certified Together series. I am recording episode number 39 today, and in this episode we will be finally saying goodbye to Domain 4, where we discuss about application security, different components around that. Like I told you, I really could have covered it in the last week episode as well. IAM is something which we are discussing about again and again. Those are like concepts which come in the baseline or which comes in the forefront whenever someone talks about security. Then we start with IAM. So IAM is something you are quite familiar with by now. I am also quite familiar with it and I have covered it again. So it was not that big topic, but I really want to cover it again in kind of like a separate topic or kind of as a separate episode. So we'll be finishing it off Domain 4 today, and Domain 5 will be kicked off as well. And in Domain 5, things will be covered around operational security of cloud infrastructure. Now just understand the whole path. You can get an idea of what we have done till now. We started with Domain 1, where we discussed about cloud basics and cloud infrastructure, what are different deployment models, service model, and created this kind of a platform on top of which we set up other domains where we discussed about application security, infrastructure, or what we actually storing on our application or on our infrastructure is data. So we covered about data security as well in Domain 2. After going through with all of them, now we are going to cover operational aspects. And why I want to give this kind of like overview to you guys, because inside operational security you will find a lot of concepts which we covered already in different domains, and you might wonder sometime that this is something I have already read about in Domain 3. This is something I already covered in for example, I can give you physical security or all these active standby of power modules, humidity and ventilation, cooling of your infrastructure, your physical data center, business continuity and disaster recovery. All these things we already covered in respective domain. I think it was in Domain 3 where we discuss about cloud infrastructure. Now those things will be coming back, maybe in bit more detail, but from the point of view of operation side. What I mean by operational side is we will be covering more towards what are different kind of faults which can come into these components and how we actually have different solution in place, how we can put different solutions to kind of like save them or to kind of recover them if there is really some kind of operational fault. Earlier we discussed more towards from the design or from the planning perspective. and this one will be more towards day 2 and day 1, where we will be operating that environment. So we will be covering many things again, but from the operational view. If you are in the tech field, you are already aware of this different departments, and operations is completely separate department. So they will be working on the same thing, they will be having the same technical knowledge, but they will be working as an operations engineer, which is completely different from planning engineer or developers or product engineers. So that's something which we will be doing in domain 5 as well. We will be starting as an operations guy. Now before that, I also told you about my first conference which I'll be attending in previous week from ISC2. I went there and it was, trust me, a great experience. There were actually 2 speakers, so one from AWS, and he told about landing zone. So AWS have this service landing zone and landing zone accelerators, where if I give you kind of like a short definition or a short insight on that, then landing zone is something AWS provide, where you can create a whole architecture using their recommended well-architected framework. Now, what is well-architected framework? It's again a big thing, but to give you a short definition, then if you, for example, want to create an application onto the cloud, or want to deploy some infrastructure onto the cloud, where you will start? You need some kind of baseline architecture, right? Now, if you are really good from cloud architect side, then you can create something on your own. But AWS or Azure or Google Cloud, they all provide their own recommendations as well to help you out if you are new to the cloud. So you can follow those well-architected framework, and you can follow those design. What landing zone essentially do is it will help you create that design, and it will refer those well-architected framework in backend and create a landing zone for you. So if you think from the gaming perspective, I think in PUBG they call it the landing zone, where all initial players, they drop from their planes. And I'm not a PUBG player, but I played it one time. I really didn't like it. So I think they all dropped, and they all drop on a central location, a landing zone, and then they start working upon that. I don't know what they do, but yeah, that's I think it's derived from that side, but that's what landing zone is. Second session was around DNS security, and that was really incredible, because in DNS security, it was more towards how people can spoof different domains, how they can create multiple domains of kind of like a famous site. For example, if you have, I don't know, if you are using Barclays banking and you have barclays.co.uk, then people can make barclays.co.uk, but A can be with a different, I don't know, different symbol, maybe something which maybe we as an end user who are in tech field, or who are kind of smart enough to figure out, we may figure out, I don't know. But if you are in rush, even you can make that mistake. But people like elder people, or people who are not that tech savvy, then they can come into this trap where they will think that this is an original domain, or this is an original website, and they can open that link. So it can of course lead to multiple things. It can lead to phishing attack. It can even install some malware onto your local laptop or local mobile device from which you're accessing that domain. You can even conduct these cross-site scripting attacks using that spoof domain. So second speaker was from Infoblox. Infoblox is a renowned DNS service provider, and his session was around how people, or how hackers, or how different attackers can use this spoofing of domains to create these kind of like attacks in different ways. Like I told, it was a great session listening to those 2 speakers, and of course in between we had kind of this networking session as well, where we can introduce within ourselves, we can talk, and we can have this kind of like informal discussion on what you guys are up to and what you guys are doing. So I also had a conversation with a couple of guys, and it was really good. So again, I'll remind that if you have something similar nearby, then you can go and get one. You can join one chapter and see if they are having some session or planning something. It's really good for us who are starting in the security field and who are preparing for this. Maybe you can have this networking with another person who have done CCSP recently, and they can help us out. So there are multiple ways anyway. And of course CPE, so you will be getting some kind of CPE points, and which will be reflected into your ISC2 membership account. And if you recall, CPEs are the points which you accumulate over the time period of I think 3 years, and that proves that you are still active in cybersecurity or info security field, and you can have your certification renewed, or even your certification kind of having this credible authentication that this person is still active in the cybersecurity or information security. So you can get those CP points only by attending it. So I attended it and I get some CP points. I haven't checked how many I get. If it's reflected in my account, I'll let you guys know how much I get. But there was certainly, because our host asked our membership ID for those points. So anyways, that's whole experience I wanted to share about my first ISC2 conference, and go check out if you have something nearby and if you can also attend something. All right, let's have a quick break, and after that break we can start on our rest of the episode, finishing domain 4 and getting into domain 5. All right, let's start with identity and access management. So IAM stands for Identity and Access Management. It's a short form or acronym for this whole authentication authorization. We simply call it IAM. AWS even have this own AWS IAM service itself. So they were kind of like first in the cloud, so they claim that name. And of course then Azure and Google have to find something of their own. But anyhow, so IAM is kind of like that concept which cover everything around identity and access management. First of all, let's begin with identity. Now identity can be anything. It's of course it's person's identity, who you are. So if we talk about from like in our day-to-day life, it's my name. That's my identity. But if you are in any organization, they provide this employee ID. They can create some kind of like earlier when I started my career, when there was no single sign-on concept, we used to get this random numbers or random maybe alphabets which were treated as kind of like your identity. Now these days we can use our email ID as our identity as well, because ultimately that email ID can be then further used for single sign-on to different application if your organization have this setup in backend. But again, identity is something using which you can recognize a person. So if I see an email ID or I see employee ID, I can go to my organization's database and I can check that who is this person and which department he or she belongs to and what they really do. And it's public available, means that's the whole concept of identity. You have to show it to everyone to prove kind of like having this first step of authentication where you say that I am this person and here's my identity. Now remember, it only show your name or your ID. It doesn't still show that you are still the person who you are. And it doesn't still show that because you have this identity means you can log into a particular system, or you can go inside a particular room, or you can tap into a data center. It doesn't work like that. This identity is just a first level of information about any person or any user or even any system. We have this service account concept as well, where we create service account for the systems to talk within each other, and those service accounts will have their own identity. Now that identity doesn't mean that you are authorized to do something as well. So next concept comes is access management, which actually cover two things: authentication and authorization. Now, authentication is something which on top of your identity help you get inside a system or help you get inside a department, get inside into office building. So you can have maybe a badge, or you can have a ID card, you can have your password, you can have different sort of authentication mechanism, maybe biometric or eye scanner. Those all will help authenticate or help prove your identity. If, for example, you go to a particular office as a visitor, then what you show to prove your identity, maybe you can show your ID card, you can show your driving license, passport. So that's your identity, and you are proving it using some kind of authentication mechanism. In this case, it's driving license. In case of organizations, it can be employee ID, it can be your ID card, your badge reader. Everything will play ultimately the same thing. They are authenticating and they are proving to someone who want to check that you are the legitimate person or you are the real user who want to go inside. Now, once you're inside a system using your username and password, once you are inside an office building using your ID card, where you can go, what kind of things you can do will be decided upon what kind of rights you have or what kind of authority is provided to you to do something inside. Once you log into machine, you SSH into machine, or you log into a server, you log into a web console of your cloud service provider. What you can do once you're inside, that is proven by, or that is on top of your authentication, which comes under authorization. Now in authorization, it's specified by the name itself. You are authorized by someone to do a certain set of tasks. So if you are a developer, you will have maybe a developer role into your application or your server. If you are in system administration, you have a system sysadmin role associated with you, and you have that level of authority to commit something inside that application or inside that server. If you are a root user, then you have kind of like full access to do anything inside the server or inside the application. That whole concept is part of authorization, what you're allowed to do or what you're not allowed to do. You can sometimes explicitly stop something from people to do. So that is also part of authorization. So you can, for example, if you are in finance department, you can view a particular bill, but to authenticate or to attest or to submit that bill for approval, maybe you can view and you can submit, but you're not allowed to send it to the next level for approval unless someone else from your department also approves or also submit that along with you, also approves that. So you are in backend, you're explicitly denied to submit or to authenticate or to attest a bill by a single approval. So you need two approvals in that case. And that's also part of authorization. So authorization really covers what you can and cannot do inside an application or inside your system. That's the whole crux of it. Now for authentication itself, we have this multi-factor authentication and single authentication. Now single factor authentication is kind of removed these days because no one wants to use them. Of course, that's really insecure if you are only relying on a single factor or on a single mechanism to authenticate any user. So we are moving to this multi-factor authentication world where you need more than one mechanisms to prove your identity. So you can have maybe a password along with OTP, or maybe a password along with your biometrics, or maybe a password along with your eye scanner. So you can have a different authentication mechanism clubbed together for proving your identity, and that's broadly covered into three different segregations. So you can have something you are, which is like who you are. You can, your eye scanner, your biometrics, that's something you are. Then something you have, which is your OTP devices or your some kind of like YubiKey or any physical device which comes with a particular OTP or particular time-bound code which only you will know and which only you can use. So that's something you have. And then something you know, which can be your password or a security questions which only you as a person can know. So these three mechanisms can be used together, either two or all three, and that actually makes any authentication mechanism as multi-factor. For authorization, we can have role-based authorization, we can have attributes-based authorization, we can have even more advanced authorization, maybe tag to location of device. So this particular rule will only be applied if someone try to access that system from this particular location. So for example, your laptop may only be allowed to work when it's connected to your office network and when it's into that geolocation. And if it gets stolen or if someone's trying to use that laptop from some random location, it won't really work because it's tagged to location based authorization. So we can have this different level of authorization as well, different ways which we can improve our authorization security. Now that's whole IAM concept. Of course, IAM in backend will rely on some kind of service or some kind of solutions which help any organization to set up this whole concept. If you're putting username, password, and you're having this role-based authentication, you have this single sign-on thing going on, you need some kind of solution in backend where if you think from a logical concept, what you really must be having, you must be having some kind of like database where all the list of users with their respective ID, respective details, as well as their authorization details, everything will be stored in there. So whenever you try to log in into your any front-end system, that front-end system will send a request of authorization or authentication to that backend database. Now that backend database is called as directory service. Directory service, as name say, it's coming from that, I think, old concept of having telephone directories where you have phone number and your name and address, everything in a book. Something similar is now in this solution as well. So you have this directory service where you have all the information of each employee or each worker inside that directory, and any application or any person who want to refer something, they can send a request to this directory and they can get that information in a reply. So that's the whole concept of directory. One of the famous or most widely used is Microsoft Active Directory, or now they have this Azure Active Directory as well for cloud-based deployment. So that's one of the example of directory solutions. Now, of course, directory solutions will not reply to anything or any request message. They need a certain set of protocol or certain set of standards as well. And that standard or that protocol is LDAP, one of the most commonly used. Again, we have different protocols or different ways which we can do it, but most commonly and widely used is LDAP, which is lightweight directory authentication protocol, I think something like that. But yeah, so LDAP is one of the most commonly or widely used protocol for accessing the information from the directory services in the backend. Now, from an end user perspective, with all these different solutions or different authentication mechanism coming in, if you are suppose working on 3 or 4 applications simultaneously, maybe you have opened your web console cloud browser in one window, and in backend you are also working on a GitLab front end, and you are also logged in into using GUI or CLI to a different system. It's quite bad for end user to key in their credential always into each application again and again. And it's worse if they have to key in different credential into different systems. And there the concept of single sign-on comes in. Now, single sign-on is nothing but having this single one-time signing. If you do that on your browser, you can open multiple applications into your browser and they all will be authenticated using that SSO session which you already have. And you can reuse the same credential as well, because ultimately all those system and all those front-end application will be connected to a single Active Directory service or single whatever directory service which your organization is using. So single sign-on helps in reusing the same set of credential over maybe a time period of 12 hours or 6 hours based on how much your organization allows. So after 12 hours, that session will be terminated and you have to sign in and you have to re-put your credentials again. But yeah, you can use the same set of credential to access into different applications. Of course, there's a risk associated with it, because if you lose your credentials, somehow it's compromised, then anyone will be having access to all your system right away. So you don't have this multiple system having different password, and if your one password is gone, the only system associated with that password will be impacted. In case of single sign-on, one password gone means all your systems where you are tagged as a single sign-on user will be compromised as well. So that's kind of like, if you say, compromise which we are doing, but of course it comes with a lot of benefits as well. And I've never seen any organization which stop user from using single sign-on. They always promote using it, because as an end user is of course much easier to use single sign-on. Now we have another concept which is federated identity, which takes single sign-on to a whole new level. This is quite commonly used if you are a regular mobile user, if you open your mobile device, or even I think it's happening in the web-based application as well, or if you open some sites which recommends you to create an account first. So they these days quite commonly gives an option of reusing your Google ID to create an account, reusing your Apple ID to create an account. That's a common example of having federated identity. So what you really is doing, you are asking this application to create account on your behalf, but you are not providing any information yourself. You are asking that application to go and check with Google or go and check with Apple and get my ID details from there. I have already created and I have a legitimate user ID with those service providers. You can go and get those details from that side and just create my account based on those details. So you're kind of reusing your same credentials, but now you're reusing it into a different website or into a different organization altogether. So that's kind of like a whole new level of single sign-on, which comes under a part of federated identity. Now it of course rely on an identity provider, which in our case can be Google, can be Apple, or can be anything which in backend we are using, and relaying provider which send a relay request, which in this case will be our front-end application where we are trying to create an account. So my front-end application will relay the request to backend identity provider, and backend identity provider will check everything and they will pass on my username password to this organization, and this front-end organization will then create a account for me, and I can use the same set of credential like my Gmail or my Apple ID to sign in into this new application or this new front-end. Some of the common standards which we use for federated identity are SAML or OpenID Connect. These are kind of like commonly used protocols or commonly used standards which help this whole federated identity concept to work. Now, of course, from an end organization perspective, this whole IAM concept is now getting more and more complicated. We have a lot of solutions in the market. We, of course, want our end users or our internal employees to have the single sign-on, to have that kind of like a streamlined user experience. But we also don't want to complicate things for them, but we also don't want to compromise anything on the security side as well. And if your security team is really good, you can of course set up something yourself. If not, then you can take help of some organizations or some companies, some vendor solutions which provide this kind of services for you on your behalf. They are cloud access security brokers, CSP. So what they will do is they will sit in between enterprise and cloud service provider. They will, based on the use cases or based on the benefits which you are looking, they will check with the CSP what kind of solutions they have, and they will create something for you, kind of like a customized solution, and help your organization set everything up. So you don't have to do anything yourself. You don't have to overwhelm yourself by looking into different CSPs and checking whether they are compatible with whatever application or whatever servers you have on-prem and how your user experience should look like. They will do everything on your behalf by doing the whole hard work themselves, and that's why they are called broker. They are doing this kind of like intermediary between yourself and the CSP. Of course, they will ask a lot of money. So if your organization is really up for it, you can pay for that and you can have services from these CASBs. Good part with this is they can create policies and they can even do configuration as well, which if you are doing yourself, you have to do everything and you have to create whole plan yourself. But if you are paying some CSB to do this for you, then you can just tell them that I'm paying this money and I want my whole organizational policy to look like this. I want this standard to be followed, and they will do it for you. So that's, of course, it saves a lot of time and hassle if you want to do it in a quicker way or if you really have a lot of money. All right, that's it for domain 4. So like I told you, I covered a lot of things in IAM in domain 4. And that's why I wanted to cover it in the next week episode. So we are covering it today. Let's move into domain 5. We don't have much time left, but at least we can kickstart domain 5, and I'll quickly cover 2 concepts related to operational security of cloud data centers. So like I said, we have already covered cloud data center before, physical security and physical environment before as well in domain 3, I believe. But we have to cover again operational point of view. Now, first and foremost, to understand when we kickstart our cloud security operations journey is everything is still on the server. Everything is still running on some physical location. Where you are putting your server, where you are keeping them, how many locations you have, is your location is near to some site or some place where you have kind of like this risk of having environmental calamities or anything. Is it really hot, or is the weather nearby is humid, or it's really cold? All these things drives where you want to put your data center at the first place. Now, of course, if you are a smaller country, or if you are in a place on the globe where you really don't have any choice, maybe you are in Middle East or maybe you are in somewhere around the equator, then you really don't have a choice of having this cold environment of choosing your location out of different options. You always have to place your data center into the hot location, and you really need your ACs to running every time, and you really need cooling to make sure your server are always up and running. But if you are in a country, for example, I think haven't worked back in India on data centers, but I'm sure companies there have a lot of option. In some of the northern part there is hot climate, but in the southern side it's relatively cooler in some place. If you go really into the hilly areas, it's much more cooler. So as an organization, they have multiple locations because they have this different geographical region in a country. I'm sure something similar will be in United States as well, because country is so big, so you have different locations from where you can choose from to deploy your data center, because environmental conditions play a big role. Now, we call all these 4 categories of environmental factors which drives the data center decisions as HVAC. Now, HVAC is humidity, ventilation, and air conditioning. So humidity is, of course, how humid is the environment, because of course water is enemy of your servers. Water and servers, they don't really work together, and that's why your environment should be, where you are placing your server should be less humid. And then we have ventilation, of course, then how you're placing your servers. If you're stacking them together, if you're stacking the racks together, are you providing some kind of ventilation in between? And then air conditioning, because everything need to be cool. Your server and heat, again, they don't go together with each other, and you want your server to always stay in a cool environment. You can have different kind of concept related to this racking, where you have this hot and cold aisle where hot air from one server is going towards the cool air of another server. So different type of layouts can be created. From the operational perspective, you of course need some kind of tools or some kind of sensors to be placed inside. Those sensors will be attached to some kind of monitoring system, and you can have this kind of real life reading where you will get all the information, what is happening inside the data center. So what kind of temperature currently is, what is the humidity level, and what's the power module status. Is there an active standby status, active standby power module, both are running or one of them is down. So you have to place all these sensors inside the data center. Another decision which drives is what is kind of like recommended action if something goes wrong. So for example, normally if we have this situation of fire, we have this water sensor which sprinkles the water everywhere and fire to help cope up with the fire in any premise or any building. But that solution is not relevant for data centers, because data centers will be spoiled if you put water on them to save them from fire. So you should be having some kind of like maybe gas or some kind of like a different kind of fire extinguisher, which without impacting your data center life actually help you deal with the fire situation. So you have to decide on what kind of actions also to be taken if based on those sensory readings something is going wrong inside your data center. Now redundancy is one key concept, because redundancy in terms of local data center, like how many modules or how many servers are there, as well as on the physical or geolocation as well. So if you are putting a particular data center in a particular location, does it have a geo redundancy on a different location, also plays an important role, and also help you decide what kind of data center or what kind of cloud operational environment you want to build. Now there can be different tier of data center as well. We can have different situation, or we can have different requirements from our data center, and based on that we can really create kind of like a fully redundant and fully compatible, fully functional data center which is always up and running. Or we can create kind of like a baseline architecture or baseline infrastructure, of course to save cost, and build a basic data center as well. So we can start with from tier 1 to tier 4. Tier 1 comes as kind of like lowermost category, where you are creating everything based on baseline requirements. So you're not thinking about creating a redundant, maybe even in worst case a power source, or maybe only redundancy on power level itself, but there is no separate redundancy. If server goes down, or if there is even a planned activity, you need to shut down your server or you need to shut down your data center. So everything is impacting the services, and it's not of course recommended on production level. Normally it's used kind of like a standby site, or hot or a warm or cold standby site if you want to create and place it somewhere, which is not always used. So it's kind of like a basic or completely zero level of baseline architecture. That's tier 1. In tier 2, we have a slightly upgraded version. We have some basic level of redundancy. We have some basic level of redundancy. We are putting in a lot of effort in creating the whole architecture. Any planned outage will not really impact the services, but unplanned outage will certainly impact the services. We can expect services to go down. We can expect applications to go down. So we have to make sure in mind to not put business critical application onto this tier 2 data center. Most commonly it's used by those smaller organizations which cannot pay a lot of money to set up the whole infrastructure. So they can create this kind of something which is on top of baseline, but which still can go down if there is an unplanned outage. But for smaller organization, maybe they won't be worried about that much. In tier 3, we have a more complex environment where you have this production level data center which is having everything redundant, and any planned outage will not impact anything. Any unplanned outage might impact some services if there is no redundancy on the application level itself. So for example, if you have 3 servers, those 3 servers itself, they are running in N+1 mode. So you have one server as kind of spare. But top of that server, there is some application which is deployed as a virtual machine, which don't have application redundancy on that VM level or virtual machine level. Then of course, if something goes wrong with that server, then application will go down. But at least server infrastructure level, everything is redundant. But if something goes wrong with the whole site itself, there is some physical calamity, your whole infra will be gone, your whole application will be gone. And that's kind of like a worst level scenario, because in this tier 3, you are setting up everything locally redundant, but there is no geolocation for kind of like a standby site on different location which have everything, and your whole business might be impacted if there is really a big outage. But those small maintenance window or those small outages, you may cope up with it without any impact. So that's kind of like production level data center, the tier 3. Tier 4 is for really business critical application, those government institution, banking industry, which really cannot handle even a few minutes of downtime. It can impact the business, or it can impact the whole government functioning itself. Those are tier 4, which have everything geo-redundant, everything is created on 2 different data center. Of course, it costs a lot of money, but no matter what will happen to any location or any server or any application, your end users will not be impacted. So that's kind of like a tier 4 data center. Of course, all these data centers, again, from operational perspective, need to have some kind of solutions to monitor the physical server status as well. So different physical server comes with their own solution or their own softwares to monitor the physical health of the devices. So by physical health, I mean your RAM is up, or your power modules are up, or your processors are working absolutely fine. Those are physical units of those are physical components of your server, and they should be always up as well to make sure your application which are deployed on top of that, or even cloud infra layer, your hypervisors which are deployed on top of that physical infrastructure is always up. Another concept is of BIOS, which is related to hardware as well. Now BIOS is basic input output system, which is kind of like first operating system which boots up whenever we turn on the hardware or server. That BIOS health is also monitored using these backend systems which are connected to your management network, which is provided by each hardware vendor. So for example, HP have, I think, ILO, Dell has iDRAC. So different servers have their own mechanism or their own way of handling this or monitoring this physical health of infrastructure. And of course, everything is connected via cable, so you can monitor the cables, you can keep them tidy, you can keep the whole area clean. I think rats is one of the big risks to cables, so you stop people from eating inside the data center, because if you eat inside the data center, then they can come and they can cut your cable. So all these are from operational point of view, how you can make sure your data center is always up and running, and how you make sure that your data center is redundant, your data center is safe, and is there any outage in that, or if there is any issue in that, you can monitor it real time based on all these softwares or all the solution provided by each hardware service provider, and you can monitor using those application or those front-end GUIs and make sure everything is up and running. All right, that's it for kicking off cloud operational security. We started with making sure our infra is operational and how we can have different tiers of data center, and how we can have different mechanism to make sure that our data center is always working without any outage or without any destruction of data or deletion of application on top of that. In next week, we will be covering the next layer of cloud, again coming to virtualization application. We will cover different concepts around that, and if in meantime I get any other news around ISC2 or anything around conferences, then I'll of course share it with you guys as well in the next week episode. Till then, please keep studying, and goodbye and good luck.
Thank you for listening to Get Certified Together. If you loved our content, then please like and subscribe from your favorite podcast platform so you don't miss the notification for our next episodes and announcements.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.